Hey everyone, Cameron here. Today I'm working through my Next-Gen FSNP SQC lab, where we have 5 troubleshooting tickets, and we have our enterprise deployment here. We have an HQ office, 3 branch routers, as you can see, a couple of edge routers in between with an edge, basically computer to test them, a DNS server here, as you can see, labeled Google, and we have a colo data center here, colocation data center here, so not strictly owned by the company, but one they would rent out, basically. So anyway, today we're going to troubleshoot these like real tickets, like we're a real enterprise network engineer for the company building this, who built this for this company. So, as you can see here, 5 troubleshooting tickets. Troubleshoot each of the 5 tickets, apply changes based on findings, verify the configuration changes have resolved the issues for each ticket. Tickets do not have to be resolved in numerical order, 200 points, 40 points per ticket. So this was a part of my Next-Gen skills qualification check, hence the point system and such. And then a couple of notes there about the ASA. But yeah, so let's get into it. First thing, let's actually, regarding these notes, let's bring up these ASA interfaces so that this thing works. So let's see here. FA03, and let me move that so it's easier to see. G11. Okay, take 11. All right. Get rid of the password. It's gonna for now. Okay, so FAG11. Now shut. We got interface. Which one is this? Make our lives a bit easier. G12. 1/2. No shut. There we go. Beautiful. Whatever. I'm just going to try and save that. Never mind. Okay, now let's do the same thing. Let's bounce port FA50. I think that was 5 on iNet router. So interface here. What's that number again? Let's see. 50. I had it backwards. Oh. 5/0. There we go. So, there we go. No. Okay. That is still down. Alright. Oh, that's why. So now let's go to this ASA interface. What was that? 1, 2 something? Along those lines? Interface 1, 1. There. Shut. There we go. Okay, so now these are all up, which is good. So now let's go on to ticket number 1. So ticket number 1, HQ PC 101 cannot ping HQ PC 102 at the HQ site. Troubleshooting should focus on HQ core switch 1 and ASA switch 1. Okay. So a couple of things we can do here. IP config. We're not getting an address, we're getting the net generic DHCP one. So let's go 8.8.8.8. We're going to speed this along. We're going to cheat a little. And because the other thing we're going to do, now packet tracer is going to get slow on me. All right. So it's not going to work. So let's just cheat a little bit more. Now let's do a Control C. Okay, so that's not going to work. And, I mean, that's just not going to work. So that's not getting out at all. So let's look at this switch here. All right. Interface G1/1, GE1/1. Right? I can't get that to come up. GE1/1. Oh, that's not what I want. Sorry. We want to do. Yes. What am I doing? What am I saying? I'm trying to do the same thing I was doing on the ASA. Let's do show VLAN brief. Okay, so what we're going to notice here is that immediately stands out to me. So we got VLAN 10 shows up on FA01 and FA02. VLAN 102 only shows up on FA02. That immediately stands out to me. So let's show VLAN brief. Let's do show run interface FA02. All right, that's not working. Let's do a show neighbor CDP neighbors here. All right, let's. Now, actually, before we do that, let's do a show run. And let's look at FA0, 1, and 2. So, okay, there we go. So, VLAN 101 is on FA1, VLAN 102, and so, VLAN 101 and VLAN 10 are on FA01. 102 and 10 is on FA02. So, look at the output. FA01, we see that both 101 and VLAN 10 are on FA01. However, when we look at the VLAN database a moment ago, we saw VLANs 102 and 10, but we did not see VLAN 101 in the database. So, in other words, this is what we call an orphan VLAN, when the VLAN is configured on a port but it's missing from the VLAN database. So we need to create VLAN 101. Oh, excuse me. No. And then we need to add it to the VLAN database. So VLAN 101 name PCS11. Exit. Now let's go to show VLAN. Okay. So now we see that showing up on VLAN 10 and 101. So now if we attempt to renew the addresses on our PCs, we'll see that they still fail. So while we find an actual problem on the network, there must be other issues. Excuse me, while we did find an actual problem on the network, there must be other issues. So, like for example, if I do the same thing I did before, see we're still not getting an IP address. Also, let me make my life a little bit easier later on. Oh, wait, do I want, well, I think it's configured for static, but well, anyway, we'll remember that for later. Okay, so now let's look at the trunking and more configurations upstream. So let's look at core switch 101 here. All right, so do show int trunk. Okay, so what stands out to me here is we can see the VLAN 101 and 102 are allowed on the trunk link to the core switch. We can also look at the VLANs on the core switch. We can see that the core switch has VLANs 101 through 103 created. Now, show int trunk. Oh, I already did that, excuse me. Now, the trunk links configured have all VLANs allowed across them, which is good. But now if we do a show CDP neighbors.
You'll need to unlock your iPhone first.
We'll see that G01 and G02 connect to router 1 and 2 respectively. They're configured with an encapsulation of 802.1q, but set to the mode of access. This won't work. We need to configure these ports as trunk links. So we're going to go interface GE01, interface G01. There we go. We're going to switch port trunk encapsulation dot 1q. We're going to go switch port mode trunk. Switch port non-negotiate. There we go. Interface G02. Switch port trunk encapsulation dot 1q. Switch port mode trunk switch port non-negotiate. Switch port non-negotiate. Did that happen? Did that take? Port non-negotiate. To make sure that took. Okay, so we're seeing here with these syslog messages is a line protocol in the interface G01 change state to up. It's now forming a new adjacency. So that's good. So that means the newly configured trunk ports are online, that a number of EIGRP adjacencies have formed. This is due to the trunk links being configured and allowing the core switch and the edge routers to communicate. So now let's do the same command again. Ooh, look at that. Everything looks as it should, which is great. So the output shows G01, G02 are set up as trunk links. The PC101 should now have an IP address. So let's check that out. See, yep, it's getting an IP address. Let's do that to that. Let's do an IP config again. It's not showing up. It's showing up here in gray, but it's grayed out. Let's switch that to static, see if that's the problem. What's going on? Okay. Maybe it's supposed to be DHCP then. There we go. That's what I wanted to see. Okay, it was supposed to be DHCP. It took a minute. Packet tracer just needed to catch up. So now we see 10.1.101.11, 255.255.255.0. And if we try to ping PC102, we get 10.1.102.11 because that's the convention there. It means it worked. So anyway, yeah, that worked. Let's look at PC102 real quick. We're going to go ping, well, IP config. There we go. Boom, beautiful. IP address. So now let's go ping 10.1.101.11, I think it was. Double check that IP address real quick. 10.1.101.11, got it. Boom, it's working. Beautiful. Easy, boom, done. Ticket number 1, resolved, and closed. We'll let our customer know. Ticket number 1 is resolved. PC101 can now ping PC102. And please verify so that we can get back to it so we can close the ticket. So there it is, guys. That's ticket number 1. We're gonna call it there and do ticket number 2 in the next video. So thanks for watching, guys. Sayonara.